Write your definition, your term, determine the center. So just using these 4 words, write your definition, draw an image of what you interpret that word to be.
How many do you want to do?
Just the one for these 4. So electron, neutron, proton, and nucleus. Just those 4 terms. So let's check in about, 5 minutes? So we'll put a timer on for that.
It's the no, so nucleus is inside both, but technically the nucleus is called the brains of the cell.
Okay, very good. Good collaboration there.
So what is the definition, example?
And then draw an image. So draw what it looks like to you, and we'll have some conversation as you guys get ready to explore this. Be specific in your terms. So pretend. I want to know, where is it located? If it has a charge, what is the charge? And how does it behave? Okay.
It's a negative charge.
Okay, it's negative charge. All right, excellent. What else do we know?
It makes up the atom.
Okay, so it's a part of the atom. So I heard someone back in the rear say subatomic particles. And so we'll call it as a subatomic particle, which means it's a part of the atom. I will confirm that. Yes, Emmanuel?
It's the defining particle that tells you how many bonds to be formed.
Oh, it's involved in bonding. Okay. Taking it to a deeper level. It's the particle that's involved in bonding. What else do we know about an electron? So the nucleus, then, let's jump to that next term. The nucleus, when we talk about the nucleus something, the nucleus of a family, the nucleus of the cell, it refers to what part of the cell?
The strong part of it.
Not the strong.
The brain.
Power plant of
The
it.
power point,
That's
the
right.
brain, but it's always the what? Where is it? If I'm drawing a
Center.
circle, there you go.
Yeah,
The
but
center.
sometimes
And you can copy this as in your notes as well. And then the other component is, we just stated earlier that the electrons move around it. You all are going to explore the early models of the atom. So a couple of things. Everybody should have their early models atom sheet. I noticed that a lot of students were using that as a reference earlier. Hold that up so they can see what that is. And then also, we're now on our stations activity. So this particular station activity allows you to work in pairs. Since we're small today, we can work in pairs so that you can have some collaboration with one another. You're going to follow the pattern through that and explore Dalton's model, Thompson's model, Rutherford's model, and the Bohr model. And I believe Chadwick's is also on there. Where Tyrone is walking to, that back station there is a manual simulation of the gold foil experiment with Rutherford. So when you get to the Rutherford, yes, very good. When you get to the Rutherford station, you can utilize those boards, and the atomic target practice instructions goes along with that particular area. Over on this side where we have the computers, that's where we're going to do the simulation for the build and atom activity, and those two are elaborations and extensions as you go through the process. I'm here to facilitate, so when you all have questions, you can ask me, but remember, ask 3 before me, and then utilize your model worksheet, and then target sheets, whichever one you want to use.
we're not over the one.
Exactly.
I think a pool ball, there's no atoms in it. Like anything that's not living doesn't have atoms.
Can we draw this one sheet?
So that's like, you have a conversation with your scientists, because remember, in this collaborative community, scientists speak to one another and collaborate on theories. So you guys should have your conversation in that process. If I'm to say to you, this is the atom, what do you know based on what we just discussed? As far as those different parts, what would you say in comparison to what we discussed moments ago in your vocabulary mapping?
They have no.
So you should indicate whatever your specifics as your evidence in your answer. Does that give you some clarity? Okay. So make sure you confer with your colleague, your peer, in reference to the statements that you all are making to those guided questions. But don't forget that you have, as a scientist, you have to give evidence to support your statement. Okay? We're good on that? Okay, continue through with that. When you get to the Rutherford cards, you're gonna use all of those cards and make them different color inks.
Right.
Okay,
Yes.
perfect.
Alright, so basically I said like based on Dalton's model, there are no negative or positive charge subatomic particles.
Observe where the marble comes out and trace the approximate path of the marble on the white paper. For example, if the marble goes straight through, draw a straight line from one end to the other on the sheet.
Go ahead, explain to me what you
What it,
just read.
from what it looked like and what I read, what I observed from reading, since this is the black box, you'll roll the marble from like different angles, and then wherever it lands at, we'll write like a circle, a line, then a circle where it stops. But if it run straight through, make a line straight through, saying it made it across.
Okay, so write it underneath and see what happens.
Close to it.
Wait a minute, there you go.
Create a total
Wait a minute, you got to. So are you rolling it with force?
top of it.
Yeah, it won't come out.
Okay, so therefore,
It won't come out.
so whatever angle that I rolled it, right? Clearly, I rolled it what angle. You have to trace which way you think it went. Got it? If the marble rolls and it goes through, then you trace that on there. So you're gonna trace it on top, okay?
On the box or just on the paper?
On the paper.
Alright.
So I'm gonna, but you cannot look underneath the box. Do you see your marble? And then you can change, let me move your paper around, so you can change this around in different angles
Alright, so
to make the adjustment. So what's, no, you can't. However, why wasn't it gonna go through that side? That was a difference.
angle and level.
So then, so how would you address level that out? Is there something you could do? Is there something you could do to level it out?
Tilt it.
Because that's actually a good question.
You can tilt it.
I mean, the atoms inversely
Tyrone,
are the same mass.
Yeah, I guess you can tilt it, but it.
So
tilted how? Lean what, this? So he's saying hold this here, because he knows it's something.